welcome back to my channel. Today we're going to look at the topic of formulae. Before we start, visit my website where you can download the worksheet which will accompany this video. Before we look at writing formulae, let's have a look at naming compounds. Where you have a compound which contains two elements, it will end in the letters I, D, E. For example, if sodium and chlorine form a compound, they form sodium chloride. Compounds which contain three elements, where one of them is oxygen, will end in the letters ATE or ITE. Compounds ending in ITE have less oxygen than those ending in ATE. Where sodium, chlorine and oxygen form a compound, this could be called sodium chlorate. Where magnesium, nitrogen and oxygen form a compound, this could be magnesium nitrite. Compounds which contain hydroxide will also have three elements, even though the word ends in IDE. Hydroxide has the formula OH, so contains two elements. Compounds that contain ammonium, NH4, will also contain a minimum of three elements. Pause the video now and identify the elements in each of these compounds. In the first compound, lithium oxide, this ends in IDE, so contains two elements, lithium and oxygen. The second compound, magnesium fluoride, also ends in IDE, so contains two elements, magnesium and fluorine. Iron sulfide ends in IDE, so contains two elements, iron and sulfur. Potassium sulfate ends in ATE. This means it contains three elements, potassium, sulfur and oxygen. Copper carbonate also ends in ATE, so contains copper, carbon and oxygen. Calcium hydroxide, although ending in IDE, contains three elements, calcium, oxygen and hydrogen. Let's have a look at what chemical formulae represents. The chemical formula of a substance indicates the elements present in a substance using chemical symbols. This can differ depending on what type of substance you have. For covalent molecular substances, the formula represents the actual number of each element that is present. For covalent network substances, such as graphite and diamond, the formula represents the ratio of elements that are present. For ionic substances, the formula represents the ratio of positive and negative ions that are present. For example, carbon dioxide, a covalent molecular substance, contains one carbon atom and two oxygen atoms. Silicon dioxide is a covalent network and contains a ratio of one silicon to two oxygen. Magnesium chloride is an ionic substance and contains a ratio of one magnesium ion to two chloride ions. Pause the video now and identify what each formula represents. In this first formula, NH3, this is a covalent molecular substance. This contains one nitrogen atom and three hydrogen atoms. This second substance, magnesium nitrate, is ionic. This contains a ratio of one magnesium ion to two nitrate ions. This final substance is a covalent network. Diamond is a network of millions of carbon atoms. Therefore, its formula is just C. The first type of formula we're going to look at is that for chemicals with meaningful names. Some chemical names indicate how many of each element are present in a molecule using prefixes. Mono means 1, di means 2, tri means 3, tetra is 4, penta for 5 and hexa for 6. For example, carbon monoxide contains one carbon atom and one oxygen atom. It has the formula CO. We don't put the mono in front of the carbon. The prefixes are generally for the oxygen. NO2 contains one nitrogen and two oxygen and is called nitrogen dioxide. Pause the video now and write the formula for each compound, and then write the names for these compounds. Carbon dioxide contains 1 carbon and 2 oxygens. This is because di means 2, therefore the formula is CO2. Silicon tetrachloride contains 1 silicon and 4 chlorine, SiCl4. Dinitrogen tetroxide contains 2 nitrogens and 4 oxygens, N2O4. NO has 1 nitrogen and 1 oxygen. This will be nitrogen monoxide. SO3 contains 1 sulfur and 3 oxygen, and will therefore be sulfur trioxide. SO2 contains 1 sulfur and 2. Let's look at writing formula for 2-element compounds. Most compound names don't indicate how many of each element are present, so to be able to write the formula we need to use what's called valency. Valency is the number of bonds that an element can form. You can find the valency of an element using the group number. The valency matches the group number up to group 4 and then goes back down again 3, 2, 1, 0. For ions, the valency is equal to the charge. For metals, it's equal to the number of electrons in the outer shell, and for non-metals, it's equal to the number of electrons required to fill the outer shell. I'm going to show you 2 different ways to approach writing formula, using valency pictures and the crossover method. Here we're looking at magnesium chloride. To draw a valency picture, you need to find the symbol for the first element on the periodic table. You write out the symbol and draw a circle around it. Using the group number for that element, you then put in the appropriate number of arms to show the valency. Magnesium is in group 2 and therefore has a valency of 2. We then look at the second element. Chlorine is in group 7. It has a symbol of Cl, so we have Cl with a circle around it. Group 7 elements have a valency of 1. Therefore, we can only join 1 chlorine onto one of the arms. We fill up the other arm with another chlorine. You can only join the opposite element to each other. You then count up what you have in front of you in the picture, and this is your formula, MgCl2. The valency picture is the working. MgCl2 is the formula. Looking now at the crossover method. The first step is to write out the element symbols, Mg and Cl. Underneath, you then write down the valencies taken from the group numbers, 2 for magnesium and 1 for chlorine in group 7. You simplify if there's a common factor, in this case there's not, and then cross over. The 2 going to the outside of the Cl and the 1 going between the Mg and the Cl. You then write this out, inserting the numbers. Where we have a 1, we can ignore this. This takes us to the same formula, MgCl2. Let's look at a second example, calcium oxide. First step for drawing our valency picture is to find the symbol for calcium. Calcium is Ca. We put this in a circle with arms for the valency. Calcium is in group 2, so has a valency of 2. We then look at oxygen. Oxygen has a symbol of O. We put this in a circle with its valency. Oxygen is in group 6 and also has a valency of 2. So both of these will match up together to give a formula of CaO. Looking at the crossover method, we write out the symbols for both of the elements, Ca and O. We put their valencies underneath, 2 for calcium in group 2 and 2 for oxygen in group 6. We have a common factor of 2 here, so we can simplify to be 1:1 ratio. We then cross over so that the valencies are on the outside of the oxygen and between the 2 symbols. This then gives a formula of CaO. Pause the video now and try these examples using your preferred method. look now at 3-element compounds. For 3-element compounds, the valency of group ions needs to be used. Group ion formula can be found on page 8 of the databook. The charge at the top of each column in this table is equal to the valency for that group ion. We can use the same methods for writing formula, but brackets need to be used where there are multiple of group ions. Here we're looking at sodium sulfate. To draw our valency picture, we need to find the symbol for sodium and put it in a circle. Sodium is in group 1, so has a valency of 1. Sulfate has the formula SO4. It's in the 2- column, so has a valency of 2. This means we need to join on another sodium to fill up the valency of the sulfate. To do the crossover method, we write out the symbols. We have Na and SO4. Underneath, we write down the valencies, 1 and 2. If we have a common factor, we can divide and simplify, but here we do not, so we simply cross them over. This means that we end up with a formula of Na2SO4. Let's look at a second example, magnesium nitrate. To draw the valency picture for magnesium nitrate, we need to write out the symbol for magnesium in a circle with its valency 2, as it's in group 2. Nitrate has the formula NO3 and has a 1- charge, so has a valency of 1. This means we need 2 NO3 groups for every magnesium. For the crossover method, we need to write out the formulas Mg and NO3. We put their valencies underneath, 2 for magnesium and 1 for nitrate. We simplify if required and then swap over. When it comes to writing the formula, we need to be very careful. We have 1 magnesium and 2 nitrate groups. This is NO3, 2. We need to put brackets around the NO3 to separate the numbers. Pause the video now and write the formula for these compounds. The valency of transition metals can change depending on the compound and cannot be identified using the periodic table. The valency is given as Roman numerals after the transition metal in the name. If this is not given, then assume that the valency is 2. You need to be familiar with Roman numerals. The same two techniques can be used with transition metal compounds for writing formulae. Here we have copper 2 chloride. The 2 is the valency for the copper. We find the symbol for copper, Cu, put it in a circle with the 2 for valency. Chlorine is in group 7 and has a valency of 1. We require 2 chlorines to fill up the valency of copper. For the crossover method, we write out the symbols Cu and Cl and put the valencies underneath, 2 and 1. You can simplify if there's a common factor and then swap over. This gives us a formula of CuCl2. Let's look at a second example, nickel 2 nitrate. The 2 is the valency of the nickel. Nickel has a symbol of Ni with its valency 2. Nitrate can be found on page 8 of your databook and has a valency of 1. It has the symbols NO3. We require 2 nitrate for every nickel. For the crossover method, we write out the symbols Ni and NO3. Underneath, we put in the valencies, 2 and 1, and cross them over. When we write out the formula, we need to include brackets around the NO3 to keep the numbers separate. So we have Ni, NO3, 2. Pause the video now and write the formulae for these transition metal compounds. Let's look now at ionic formulae. This is used to show the charges of ions present in ionic substances. Brackets need to be used where there are multiples of an ion. To work this out, you need to know that metals form positive ions and non-metals form negative ions. The charge is equal to that of the valency. For example, in sodium chloride, we have a metal with a valency of 1, Na+, and a non-metal with a valency of 1, Cl-. In K2S, we have 2 potassium ions, each with a valency of 1, so that's K+, brackets around them and the 2 on the outside, with a sulfide ion of a charge 2- as it's non-metal with valency 2. In this example, the charge of the iron, which is 3+, can be worked out from that of the oxygen. Each oxygen is 2-, and there are 3 overall, so therefore the overall negative charge is 6-. With there being 2 irons, each of them must be 3 positive. These have to go in brackets with the 2 on the outside. For the oxygen, it is 2- with the 3 on the outside of the brackets. In this final example, calcium has a valency of 2 and is a metal, so is Ca2+. Nitrate ions can be found on page 8 of the databook and can be copied directly as NO3-. There are 2 of them, so they need to retain their brackets with the 2 on the outside. Pause the video now and try and write the ionic formulae for these examples. Lithium is a group 1 metal, so has a 1 positive charge. Fluorine is a group 7 non-metal, so has a 1 negative charge. Magnesium is a group 2 metal, with a 2 positive charge. Bromine is a group 7 non-metal with a 1 negative charge. There are 2 of them, so they need to go in brackets. Potassium is a group 1 metal, so has a 1 positive charge. Hydroxide is a group ion that can be found on page 8 of the databook with a 1 negative charge. Sodium is a group 1 metal with a positive charge. There are 2 sodium ions, so these need to go in brackets with the 2 on the outside. Sulfate can be found on page 8 of the databook and has the formula SO4 2-. We have copper carbonate. The charge on copper can be found by using carbonate. Carbonate is on page 8 of the databook and has the formula CO3 2-. The charge of the copper must balance this 2- charge and therefore must be 2 positive. Ammonium can be found on page 8 of the databook and has the formula NH4+. There are 3, so this needs to stay in brackets with the 3 on the outside. Phosphate can also be found on page 8 of the databook and has the formula PO4 3-. Thank you for watching my video. I hope that you found it helpful. Please remember to subscribe and ring the bell to be notified of new videos when they become available. You can also follow me on Twitter at MissAdamsChem and Instagram MissAdamsChemistry for updates on videos and flashcards throughout the year. Bye for now.